so if you want to go and you want to practice more of the basics, meaning you feel there's still a couple of stuff that you are misunderstanding, a couple of stuff that you might want to practice before you get to more the past paper question type of stuff, you can go and you can do that worksheet from the notes. All of the memos are there, you're more than welcome. But you will see now when we start working through the IB papers, there's a couple of things you will pick up. Number one, they hardly ever ask you to locate a triangle. And if they do, it's normally in section B, it's not in section A. Got it? So we are going to do a couple where you have to locate a triangle, but if you find that you still want some practice on locating triangles, then please go through that revision worksheet. Now I know time is a factor, and I know you guys are plenty busy, and I know mathematics is not your only concern. I am fully aware of this. Okay, so you might not have time to do both. You might not have time to go through that worksheet on locating triangles that we were busy doing yesterday, and do the past paper worksheet. So what's more important? The past paper worksheet. So that's why I'm going to be moving away from those notes, the exercises from the notes. If you still want to do it, you're more than welcome. But to me, it's more important that you do more of these past paper questions than from that notes worksheet, or notes exercise, I should rather say. But if you do want to go and practice, memo is on the Google Classroom. Okay, so let's start looking at questions. And this is going to be a mix of questions. So we not only have to figure out how to do it, but also have to figure out, is this actually a proportionality question, or is this a similarity question, or potentially, is it both? Got it. So in this first question, right over there, to be a proportionality question, there are two things I have to have. If I don't have those two things, I cannot treat it with a proportional division theorem. Can anybody name the two things I require? A triangle and parallel lines, Bonga said. Okay, so I need a triangle and I need parallel lines inside the triangle. When I do similarity, I require two triangles. Do you understand? And I do not require parallel lines. So please understand, one triangle with parallel lines, that's the proportional division theorem. Two triangles without parallel lines, that is my similarity theorem. So that's your general rule of thumb. But you're going to see we do get at the end to slightly more complicated examples where you are going to go, I'm not exactly sure what's going on here. That's okay. It's really okay. Okay, I feel like that a lot. So this was in the 2014 final exam, and it's question 4B, and it says, let me zoom in a little bit so the back can see. And just on the diagram so we can do the birthday card information. Okay, so in the diagram below, P, Q, R, and S are points on the circle. So immediately, what do I know about P, Q, R, S? It's a cyclic quad, because I've told you this before. If they tell you 4 points are located on the circumference of a circle, then if I join those 4 points, it's automatically a cyclic quadrilateral. And also, all 4 of those lines are chords. Got it? Because 4 chords that are connected to each other forms a cyclic quadrilateral. Then it tells me that angle PQR is equal to 90 degrees, which has been given. PS and QR produced meet at E. The word produced means it's a straight line. So you can use exterior angles of a cyclic quad, you can use angles in a straight line, you can use all of that because produced means it's a straight line. And then it says RS produced meets the line through E parallel to QP at D. So luckily, it's a very cumbersome way of telling you the lines are parallel, but luckily that's also been indicated on the diagram. Okay, so currently what we can definitely use is we can use the properties of a cyclic quad. We can do that. And we can also go and we can use any of the properties of parallel lines. So let's look at the questions. And I picked this one because this was a very nice scaffolded question. This comes from section A, which means instead of just dropping a 6 or even an 8-mark question on you, it gives you like these little nice 2-mark questions. So the first question then says, why is angle DER equal to 90 degrees? So just a reason. Can anybody give me a reason why DER is 90 degrees? Yes. DER, absolutely. Co-interior angles because of the parallel lines, 100%. So let's write that down. And what I'm going to do from now on is every single time I find brand new information, I'm going to put it on the diagram, but I'm going to do it in a different color. So you can see that information was not initially put on the diagram, but because I figured something else out, I can now put it on the diagram, I can use it. So I don't know if you can see the purple, I'm going to do this in purple. So I'm going to put that in there saying, now I know that's also a 90-degree angle. Now the next question then says, why is angle S2 equal to 90 degrees? Can anybody supply me with an answer to why S2 is 90 degrees? Oliver?
This might be a long way around, but I said S3 is equal to Q because opposite angles of the side.
Careful, they're not equal.
I mean, they're not equal. Well, in this case, they are. They're equal to 180, so therefore they're...
Yeah, but just don't make the statement equal. You have to make the statement S3 is equal to 180 minus Q. If you just tell me S3 is equal to Q, then that's actually the wrong statement. I know they're equal.
I said S3 is equal to 90. I just said
that's fine.
Okay, so well, S3 is equal to 90 because Q is 90 and therefore 180 minus 90 is equal.
100% correct, there's a shorter way. Yes. Exterior angle of a cyclic quad. So you can actually just say exterior angle of a cyclic quad. And the reason I'm not writing it in the normal Euclidean geometry fashion is because they don't actually ask you calculate or prove, they just ask you why. So all you have to supply is you have to supply reasons. That's it. Okay. Next one. Prove that triangle DER, so let's highlight that, is similar to triangle ESR. So DER is over here. And ESR is over here. Tiny little triangle over there. And obviously, they have led you to this, meaning they've already made you prove the two 90-degree angles. Can you see that? What will be the second one? So we've got the two 90s, we've proven that. I'll write that down just now. What will be the second one? Can you spot it? It's something that in grade 9 you always missed on congruency proofs. Yes. They're common. Common angles, just like with congruency proofs, we always miss the common sides. So please remember, if two triangles share an angle, we call that a common angle. So you can just write it's common. So in this case, because there's not a lot of space, I'm just going to go and say 1, 2, 3. You guys know me. I normally write in triangle blah 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 and triangle blah blah blah, but they haven't given me enough space. And by the way, just in case you were wondering, do they mark that first statement? No, they don't. So if you do want to save time on your similarity proofs by simply just doing the 3, that's fine. However, you're only allowed to do that if they state the two triangles that you are supposed to be proving similar. If you do the examples we did yesterday, where we first have to locate the two triangles, then you have to start with telling the examiner what the two triangles are. You can't just start and expect the examiner to go and figure out what the two triangles are. You have to tell them what the two triangles are. But, I mean, if the two triangles are already there, you don't have to write it again. Okay, so this saves a little bit of time. So we can start by saying angle E1 plus E2, if you want, or you can just go angle DER, is equal to angle S2, which is 90 degrees. And you can just state there, proven. And then we can go angle R1 is common, which means the third pair. In this case, I've done the E, I've done the R, so what's left is angle D in the big triangle, in the yellow one. And there, I've done the S, I've done the R, so what's left is the angle E in the small triangle, the orange triangle, so that's E2. And that's just going to be sum of angles of a triangle. And please remember your conclusion, therefore, triangle DER is similar to triangle ESR. And the reason angle, 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 or equiangular triangles. Okay, please remember, people, I've said this quite a few times to my maths class over the years. Answer the question. Answer the question. So after you've written down your final answer, just check, make sure you've answered the question, which is you've proven the two triangles are similar. If you write those 3 steps down, but you don't do that final step, you haven't answered the question. So they might penalize you for that. Okay. Then we go to the next one. If ER is equal to 6, so ER, and DR is equal to 10, so DR, calculate DS. And then you look at it and you go, darn, DS. Don't have that. That's a problem. You see what I'm saying? So this means we are going to have to go back to the diagram and get a better idea of what we are talking about over here. So let's put it on the diagram. So ER is 6. I'll put it in the purple again. DR is equal to 10. And then hopefully you guys will realize something again. What do you realize? What's that? Pythagoras. Crazy Uncle Pythagoras. Always. They just love dragging him into every conversation. Okay. So if there are 90-degree triangles, please, people, always consider Pythagoras. So we can start with Pythagoras, and what can we calculate using Pythagoras? DE. So we can say DE squared is then equal to 10 squared minus 6 squared. And you can just chuck that into your calculator if you really want. So on your calculator, you can simply find the square root of 10 squared minus 6 squared. Or if you know your Pythagorean triples, which is a very nerdy thing to do, then you'll know that that one is going to be equal to 8. And you can just write units or even leave the units out, because you'll see they left units out, so they can't actually penalize you for leaving the units out. Okay. Right, so now we've got DE as well. So I can now look at DE over there. So we're still trying to calculate DS. On the diagram, DS is located over here. So if you think about it, I've got DR, so what do I need in order to calculate DS? I need SR. So I can go back to the triangle and I can say, okay, what I need is I need SR. So I've now made it a little bit messy over there, as you guys can see, because we've got DR, we've calculated that. We've got ER, we've calculated that. And we've calculated DE over there as well. So we can then go and we can say to calculate DS, sorry guys, just trying to figure this out. Oh, we've got ER. I keep on missing that. We've got ER because that's a common side. That's better. So I will then go, and sorry about the messiness, I'm going to ignore this part right there. I'm going to ignore that. And I'm going to go and say SR over ER is then equal to ER over DR. And that's going to be because of similar triangles. Do you guys agree with that? So SR is what we want to calculate. We've got ER, it's equal to 6. ER is still equal to 6. DR is equal to 10. So actually, that was unnecessary work. It was actually unnecessary work. We actually didn't need it. Okay. So I can multiply both sides by 6. And if I multiply both sides by 6, I say 6 over 10 times 6 is going to be equal to 36 over 10, which is, I think, 18 over 5, if I'm not mistaken. Let's just double check. 18 over 5. Not done yet, because we haven't answered the question. We still need to find ds. So as I said to you guys, ds is then going to be equal to dr, which is 10, minus sr, which is 18 over 5. And then I can round it off to 1 decimal place. And that's going to be 6,4 units. Which means this actually was not necessary. But sometimes, like I said, we go on a bit of a tangent before we get to what is necessary. Okay, it's not wrong, it's just not necessary. So eventually my answer, ds is equal to 6,4 units. Everybody got that? So I started this off with something fairly simple, fairly straightforward, fairly easy. This is a Section A question, so Section A questions generally, they do kind of lead you towards it. So I'm just saying, don't ignore this entire section, because it's quite possible that you might have a Section A question in the final exam on this. And you guys agree, these were pretty easy marks, especially that last 5 marks looked difficult until, well, I looked at the diagram and you realize it wasn't that difficult. Okay, so let's look at the next one. So this one says, in the diagram below, C, D, E, and F are points on a circle. So again, you can actually join up these 2 points to make it a cyclic quad. You're 100% allowed to do that. Constructions are always allowed, as long as you indicate them on the diagram. And you normally have to write them as well. You'll have to say join FE or construct FE if you want to use it. Okay. Then line MN is a tangent to the circle at E. Line AF intersects the circle at C, and then AB is parallel to DF. C1 is equal to C3. So it looks like the information that they haven't given on this diagram is the fact that C1 is equal to C3. That's currently not indicated on the diagram. And that is also why it's so important to read through the information so that you don't then go and miss something that they should have given you. And by the way, they do that on purpose. They do it on purpose where they'll put 80% of the information in the birthday card they'll put on the diagram, and there'll be like 1 or 2 things that they don't put there, because one of the skills you have to have in mathematics is to transfer English into mathematical notation, or in this case, mathematical diagrams. You have to have that skill. So they're actually testing that skill to see if you're reading through it and making sure everything's on the diagram. Okay. Now, the next question then says, prove that triangle CBA, so let's highlight that. So C to B to A, that one, is similar to triangle CDE. So C to D to E. So you guys, please see if you can do this on your own, and then we'll discuss it. So I'll give you some time to try it on your own.